Okay, hello everyone. Welcome to this talk. My name is Vinod Kaul. I'm the senior tech lead in Qualcomm Landing team. I work on a bunch of IoT platforms as well as I'm the upstream into a couple of subsystems. So IoT space, we have been working on Qualcomm boards for almost 10 years now. So this is basically a brief overview of what we have been doing for the last few years. What is the hardware story? What kind of boards are available? What is the software story? What kind of software is available? And the current evolutions that we have been talking about, which luckily got featured in today's keynote as well. Okay. Yeah, so first on this side, we have Dragon boards, which you might be very familiar with. The first Dragon board was Dragon board 410C. It features APQ 8106 SoC. This was launched way back in 2014. It, in my opinion, is quite a widely popular board, and it was compliant to 96 board spec. So it found its way in lots of industrial application. There's a good community forum which was built around it, and Linaro was very instrumental in helping to do that. Then it was followed up in 2015 with a second Dragon board, which is Dragon board 820C. It's kind of with the extended form factor. That extended form factor helped integrate more functionality like Ethernet, audio jack, and stuff like that. But then it's again compliant to 96 board spec. So one of the features of all these boards that we'll be talking about today is that there's a low-speed header. That low-speed header helps you integrate a lot of slow-moving applications. And then there's the white connector you can see on the picture. That's the high-speed header. You can connect your MIPI devices, cameras, displays, and stuff like that onto that. So this was the first initial rounds of Dragon boards which were launched by Qualcomm. And then there was a bit of brief period of hiatus when not much happened in this space. And then we had in 2019 the last Dragon board. Dragon board 845C was launched. It was launched in 2019, and then it was rebranded by Qualcomm as a robotics board. So this was also the first robotics board, RB3. It featured the SDM 845C, or as on this board it was referred by marketing as SDA 845C. And one of the good features in that was that it had the Type-C support integrated. Next year, it was followed up with the RB5 that features the QRB5165 SoC, which is kind of similar to SM8250 Kona SoC. It was launched in 2020. It's similar to RB3, but with a more modern SoC. If you look at the form factor, look and feel, they almost look similar. But quite powerful. It was also quite popular. You can you can find it like in lots of applications and people using it in a lot of industrial and IoT applications. Then last year, in 2023, Qualcomm launched 2 more boards. This is the first time we had 2 boards in the same year launch, RB1 and RB2. The RB1 is a low-end robotics board, whereas RB2 is kind of a mid-tier board, and RB1 features QCM2290 SoC, and the RB2 features its higher order cousin 4290 SoC, and both the boards have the same carrier boards. It's just that the SOM is different on these 2 boards. Okay, and this year, Qualcomm has launched RB3 Gen 2. You can find it down in the display, and this features QCS6490 SoC. Okay. So this was about the hardware story. Along with this, as part of the 96 boards, what Linaro and our community engagement, we offer bunch of peripheral boards or mezzanines, which you can help to integrate your applications and test them out. So there are a bunch of ones, but I have kind of listed down the most popular ones. So the first one is Vision Mezzanine. It supports 6 high-definition Maxim integrated Max 9286 controllers, and this is used by a lot of people, especially on Dragon Board 410C, to integrate camera applications. Then there is a secure mezzanine for your secure applications using SLB 9670. Then STM sensor mezzanine board, it integrates a bunch of sensors like movement, pressure, sound. It features another STM MCU. Then for your fun projects, people try to use Linker Sprite mezzanine card. That features analog, I2C, GPIO, ADCs, and other things. And people have really built some cool, fun applications using this board. The last one in this picture slide is, in my opinion, one of the most important ones. That's the serial adapter board, mezzanine, and especially on the older Dragon boards like Dragon board 410C and 820C, we actually didn't have a Ethernet serial port support on the board, so this was very essential to get serial logs. But on from RB3 onwards, there are additional serial ports, so you can either use this one or on the board serial port. Then another sensor board, this is sensor mezzanine. This is basically for IoT sensor applications. It actually is Arduino and Grow compatible, and you can connect your Arduino and Shield, Arduino compatible shields to this. I'm an audio guy. I have worked a lot in audio, so I used to love the audio mezzanine which was built. It features a couple of onboard digital microphones and a jack adapter. Along with that, there are Grow expansion boards which you can use to connect your speakers to. MIPI adapter mezzanine, so if you're building your own image sensors, instead you can use this MIPI adapter mezzanine, and this adapter mezzanine helps you integrate your sensors to the board. Then for Ethernet applications, there's Ethernet mezzanine, which features Power over Ethernet PoE support. And since we are talking Qualcomm, we cannot talk about Qualcomm without talking about the great LT modems they built. So LT-CAT M1NB mezzanine is available. There's another one, which is Quactel EC2 to have your network connectivity and LT modem connectivity included in. So this is kind of hardware support, and now I'm going to switch to what Linaro does best, which is the Linux and software support. So on Linux side, if you kind of buy this board, excuse me. So if you buy this board from the vendors like, what's that name? Thundercom, and so they will you will get Android images or the Yocto support from them. But what Linaro typically has been doing since 2014 for these boards is to upstream Linux kernel support and then build Debian and Yocto images for these things. So this is just a screenshot of our Qualcomm releases website, where Linaro Qualcomm landing team website, where we actually do regularly publish Debian and Yocto builds on top of latest greatest LTS branch, and there are also snapshots on top of latest kernel RCs which you can use. There's Linaro branches available for people to play around with on our Git project, git.linaro, or now codelinaro.org. So what we started is, when people had these boards, is to integrate everything. There are some user space application which Qualcomm uses, and we integrate those and give a complete package so that people can use. It started out with Dragon Board 410C, and we have continued the trend. You can find images for RB3, RB5, RB1, RB2, and we in future will also give the images for RB3 Gen 2 as well. So this is about the Linux kernel. Yeah, whole of the things are available in that. This is kind of bread and butter, which people do expect Linaro to do. So what else have we been doing? So in the morning, my colleague Caleb had given a detailed talk about this. I'm going to just briefly touch upon it. So what we have done is also integrated U-boot support. So initially, the U-boot support was not done by us. There was a community enabling on the Dragon Board 410C for the U-boot. And now what we have done is Caleb is the Qualcomm maintainer for U-Boot, and they are trying to upstream support for multiple Qualcomm SoCs. RB3, RB5, RB1, RB2, SM8550, 8650, the exhaustive list was actually in Caleb's presentation. So this is quite interesting because it opens a different kind of firmware typically is closed. So this allows people to play around with the firmware space on these Qualcomm boards. And one of the things in U-Boot is that, yes, we use device tree, but then what device tree which was used on these platforms was their own implementation, and then that's kind of not great. So what Caleb did was take the common device tree from upstream and unified that. So we have a common device tree implementation across U-Boot and Linux kernel available now. One of the target applications when we had in mind to enable U-Boot was basically to do something called unified boot. That's something we enabled last year. So imagine you're a system integrator or you are trying to build an application and you have a couple of boards. You don't want to maintain different images, different branches for these kind of things. So what we enable in this case is something we call unified boot. So today you can build an image with U-Boot support from us, and then for example, a thumb drive that can be plugged into DragonBoard 410C, boot mainline on it, and it can go all the way up to RB1, RB2, RB3, RB5, all of the boards with a single disk image. You can boot on all these bits. This has been enabled by the great upstream support we have been doing in the past for these boards. So the Linux kernel is common, as it should be. And from what the challenge we used to face is that the device tree is again board specific, but what we have done in this case is we have abstracted the device tree into the U-Boot. So the kernel device tree, U-Boot would hand over the device tree to the Linux kernel to boot. So all the board specific dependencies actually taken care of by the U-Boot for us. So U-Boot was done. What next can we do about it? So that was the next interesting application that we come up with. So let's get compliance into the picture and do SystemReady-IR. So since U-Boot is upstream, it is EDK2 compliant, and that essentially meant that we had to do the initial little bit of more incremental work, and boom, we are SystemReady compliant. So this was also featured by Lindert in his keynote today morning. So work is right now ongoing to get the certification done, because there are some bunch of technical steps we need to do. Right now, if you take the Fedora Rawhide images, they just boot straight away from USB. Nothing needs to be done about that. And as I was mentioned, Caleb earlier gave a talk detailing all the steps on this. Any questions? Yeah. So this is it, and what else are we going to do in the future is more robotics boards are coming in by Qualcomm. All of those would be supported in upstream. More U-Boot support, the features in U-Boot will be added. And one of the things which Qualcomm is doing, the RB3 Gen 2 board actually doesn't have ABL. It supports UFI, and we are going to start working on UFI as well. So this is kind of on our roadmap for now. Okay. Questions? Yep.
So I have two of these kits from 1.5-2 years ago.
Which one?
RB5.
Okay, great.
The expensive one. What's the is there a migration path from people who've invested already some time on the older kits to now get the clean bootloader in there and the system ready kind of version?
So RB5 U-Boot images are available today. If you want to use that, you can try them out. You can get SystemReady-IR compliant on RB5 as well.
Okay, but the tooling on ThunderCom is...
No, I'm not talking about the ThunderCom images. So
okay.
Yeah, that's downstream. So what we are talking about here is the upstream images. So you can take our tooling or Linaro images available. So yeah, as I said, we have unified boot. You can have the same application which you have built on RB5 on top of upstream with Linaro images. You can port them exactly same thing should work on let's say RB3 Gen 2 or the future boards from Qualcomm.
Okay. So all of that Thundercom stuff with like the SDK manager and everything, that's going to go away? Or will
So we don't use that. That's downstream.
Yeah, okay.
Okay.
All right, thank
Yeah, but Qualcomm is probably trying to do stuff there, and you can talk to Qualcomm people about it. Porting them may be easy or not, I don't know.
Yeah, so that's kind of the missing part when I learned about it like a few months ago. There was no kind of evolution of, okay, if you invested on the Thundercom dev kits, where do you go from there, you know? That was the challenge. All right, thanks.
Okay. Okay, that's it, folks. Thank you very much for your time.